So in this video, we want to learn how to find the measures of exterior angles of a polygon. Not only the sum of all of the exterior angles, but how to find the measure of one exterior angle of a regular polygon. So let's see how to proceed. Christina walks around a four-sided plot of land, and she writes down the number of degrees turned at each corner. What is the sum of these numbers? Can you draw yourself a picture of this scenario and see if you can determine what the sum of those angle turns would be? Well, let's see, maybe if you have your four-sided plot of land. So you walk this way, and then you turn that angle. And then you walk along this path, and you turn another angle. You walk along that path, you turn another angle. Walk along that path, and you're back where you started. So did you come up with maybe a 360-degree turn? So that might motivate this conjecture for you. For any polygon, the sum of the measures of a set of exterior angles is 360 degrees. And here's a nice little geometry sketch pad to show you why that's true. And notice this time I had a five-sided figure. I had a pentagon. I could create a figure with any 6, 7, 8, 9 sides. Can you tell that the exterior angles are in different colors? So what I'm going to do is I'm going to run my demo, and you'll see the exterior angles coming together at a common vertex. And that vertex makes a circle for the 5 angles. I know you were enthralled by that, so we'll do it one more time. So it doesn't matter how many exterior angles we have, 5, 10, 20, 100. The sum of the exterior angles is 360 degrees. So now let's use what we did yesterday. Yesterday we had the polygon sum conjecture. You might remember that as the sum is equal to 2 less than the number of sides multiplied by 180. Now that's for the sum of them. But if we want the measure of each interior angle, so we want the measure of one angle. Well, since it's an equiangular polygon here, we know that all the angles are the same measure. So if we divide the angle sum by the number of angles or the number of sides or angles we have, we'll get the measure of one angle. Again, that works only when it's an equiangular polygon. Now, we had that exterior angle sum conjecture that said that the sum of the exterior angles was 360 degrees. Well, knowing that, could we determine the measure of an exterior angle, just one, again, in that equiangular polygon? What do you think it would be? Well, if we take the sum of the exterior angles and we divide it by the number of equal-sized angles we have, we'll get the measure of one of the exterior angles. So 360 divided by n gives us one angle when the polygon is equiangular. So from there, we can develop a couple things about these equiangular polygons. If we want to find the measure of each interior angle, we can use either of these formulas. Oh boy, we need two. Well, we just came up with one of them. One of them was from the polygon sum conjecture, which said that one angle was equal to n minus 2 times 180 divided by the number of sides or the number of angles. But there's another one as well. Let's play with that one a little bit. So I'm going to draw a little bit of a picture of some kind of a polygon that I have. The other sides I won't draw in. Here's my exterior angle. I know its measure is 360 divided by n. Well, do you notice that the exterior angle and its interior angle form a linear pair, thus supplementary? So then the interior angle is 180 minus the exterior angle. Now you might be saying to yourself, are these two equivalent? A little bit of algebra shows that they are. I'm going to start with my 1 over here, my n minus 2 times 180 divided by n. First, I'm going to distribute. And I'll get 180n minus 360 all over n. I think you can see where we're going now. If I separate my fraction, I get 180n divided by n. Subtract 360 divided by n. And as you can see on the left, the n's cancel. And that gives us 180 minus 360 over n. So we can use either one of those. All right, let's do some problems now. Let's see if we can determine the measure of an exterior and interior angle of a 20-sided regular polygon. Well, we know it has 20 sides. We know it's regular. Remember, regular, all sides and all angles, the same measure. So if it has 20 different sides, maybe we'll say that we can find the exterior angle first, 360 divided by 20. So each exterior angle would measure 18 degrees. Now, let's be smart about this. The exterior angle is 18 degrees. The interior and the exterior form a linear pair. So then, therefore, our interior is going to be 180 minus 18 degrees, which is 162 degrees. And one last one to play with. Let's say a regular polygon has an interior angle measure of 175 degrees. Can you find out how many sides this polygon has? Well, if its interior angle measures 175, wouldn't its exterior angle be 180 minus 175, which is 5 degrees? And if I do 360 divided by 5 degrees, I'm going to get 72 different angles. So this polygon has 72 sides to it. Now, did you maybe solve it going the other way? Did you maybe say that 175 equals n minus 2 times 180 over n, and multiply by n, solve from there? You could do that as well. Either one is fine. It'll get you to the same answer. So hopefully in this video you learned something about the exterior angles, their relation to the interior angles as well. A lot of nice relationships there.